Good morning, everybody. Today's topic is going to involve refraction of light and how transparent substances will refract light. Our main objectives today are to investigate how light is transmitted by different materials, and that means basically how light travels through different materials. And we're going to describe differences in optical properties of these different materials. Okay, and we're talking today specifically about refraction. So if you remember from earlier lessons, refraction of light is the bending of light. So if you can see here up on the PowerPoint presentation, we have a young lady, it looks like here, is looking into the water, and the arrows are kind of showing this is her line of sight, and she sees the fish sitting here in the water, whereas in actuality, because the refraction of light, the fish is actually lower than it appears to be. And this optical illusion is because of the bending of light, the refraction of light. So I want you to think about that. Have you ever had experiences where water seems to distort your vision and what looked like something that you were witnessing is real? And it's not that it's not real, I guess, but it's not, it's kind of an optical illusion because it's not where you exactly expect it to be. And you've probably seen this before in a situation where you've got something in a glass of water. As you see here, we've got a pencil sitting in a glass of water, and you can see that it looks like it has a slight bend. And I did not take that photograph, but I assure you that that pencil is perfectly straight, and it's the illusion that it's being bent. Okay, so I think the big ideas here is you need to know that light, as it transmits through one substance to another at an angle, and we'll talk about what that looks like, that light will bend, and there will be some reflection, but there will also be refraction. Okay, it only refracts if it moves from one substance to another. So, for example, if you've got a pencil out in front of you and you're looking at it in the air, let's see here. I've got pencil or a pen. I'm seeing it as it is because there's no refraction of any light. It's traveling just through one medium, just the air. It's not distorted. Okay. What we're talking about is a scenario where the pen being in, or a pencil being in a glass of water, we are looking from the outside. So we're going through air, through water, and then we're seeing the pencil. Okay. And so if we're talking about a scenario where we're underwater and we're looking at something underwater and we're underwater, again, you're not looking at refraction of light in that scenario because the light is traveling only within the water. Okay, and so how does this occur? And really, what comes down to, you need to understand that light, there's a speed due to light. And the speed of light in a vacuum, so basically in space, is 300,000 kilometers per second. And when it strikes or hits or transmits through different media, okay, there are particles there. And basically, the more particles that are there, light slows down. And so when you think of air going to water, light is slower than in a vacuum, but as it passes through the air into the water, it actually slows down even more. The density, if you will, of particles has changed. So the air is less dense than the water, and therefore as the light transitions from the air to the water, it will bend. And we'll talk about how that looks in diagrams here, because it bends a little bit differently if it goes from the water and transitions to the air. So a big idea that we'll talk about here is going from a less dense to more dense media or substance, or the opposite way, going from more dense material to a less dense material. And that will affect the direction of how light is bent. Okay. So got a little analogy here, and there's a great video I found online too, Bozeman Science, I believe, And he goes through this, but it's a really good analogy. And so I'll do my best to explain it here for you guys as well. But it's got to do with, you imagine a row of soldiers here, okay? And there's obviously 4 or 5 rows of soldiers here, and they're going from firm ground, and then as they're moving, they're moving towards this muddy area here. And so we've got this boundary, the transition from firm ground to mud. And for the purposes of our conversation, you got to imagine that this is a very abrupt transition. Okay, so it's not a gradual transition. It goes immediately from firm ground to mud, kind of like the surface of the water. If you think there's air and then all of a sudden it's water, there's no shady area, if you will. So we have the row of soldiers, and they are staying equal spaces apart here. Okay, and if you notice, as the soldier transitions from firm ground, you could imagine as they transition to muddy ground, they start walking slower. Now, for this analogy to work, you have to imagine that the soldiers are doing their best to make sure that they are equal distance apart here. So the distance between each of them is the same as it is here. Okay. And you'll notice though, as they slow down, the soldier next to him will start slowing down. So these guys are still going quickly over on this side, and these guys are slowing down. So basically, when that final soldier comes in here, it appears that they have changed, right? In fact, they have changed direction. There's a slight bending due to the transition from, in this case, this would be considered a less dense area to a more dense area. All right, and so we're looking at our a diagram of a situation in which we're refracting light. I want you to know, we'll talk about, here's the angle of incidence. I don't have it on this diagram here, but this line is what we call the normal line, okay? This is the boundary, so we've got the boundary between, in this diagram, air and a diamond, and the normal is always perpendicular to that boundary. In other words, it's 90 degrees to the boundary. Okay. And I believe on another set of notes I have for you guys, I have this labeled as the normal line. It's very important that you remember this line here is the normal line. Okay. This is a boundary line or a transition line. It's going from one substance, air in this case, to another substance, diamond. And if you notice here, the light ray coming in and to the boundary here, this angle between the normal and the incident ray is called the angle of incidence. And quite often it's labeled with a lowercase I and maybe a theta as well. And then the red arrow indicates the refracted light ray. And notice that this between, again, the normal and the light ray is the angle of refraction. Okay, so this is the angle of the light ray that is coming from the other side of the boundary to this side of the boundary. Okay, so angle of incidence, angle of refraction. So now let's take a switch over and take a look at a simulation I found online that takes a look at how light is refracted between 2 different mediums at a transition or a boundary. So here we have one substance. Here in this case, the material is air, and then we've got our boundary line. And then this material down here in this case is water. And we are going to shine a laser. Now at this point in time, we have our laser is set to 30 degrees from the normal. You'll see here that as it hits the boundary, it does bend. You know it bends because if it didn't, we'd expect it to continue straight through and it would be at 30-degree angle here, but it's not. In fact, if you look carefully, we are at what's that, 5, 10, 15, 20, about 23-degree angle of refraction. So angle of incidence, 30 degrees, angle of refraction, about 23. And another way we talk about this is that, see, we'd expect it to be over here, but it's closer to the normal. So when it goes from a medium that is less dense to a medium that is more dense, it bends towards the normal. Okay, remember this line here is the normal line. It's always perpendicular or 90 degrees to the boundary. Okay, so that is what we'd expect here for less dense to more dense. And I just want to take a moment to mention here, you can also see that we've got some reflection. And reflection is absolutely normal as well when we are talking about a transition between two boundaries or two materials at a boundary. You can think, for example, you're looking at mountains and there's a lake in front of the mountain. Quite often, what do you see in the lake? You see a mountain reflected in the lake, right? Or if you're out fishing, you might look in the water at a boat, and you might see the reflection of a boat or something like that. And so there, yeah, we'll have refraction of light, obviously, as light enters the water, but light is also, we know light reflects off of water, especially, right? It's those shiny surfaces that we talked about before. Okay, so there's still that going on, and we can change the angles here a little bit. Like if you notice here, the incident angle now is 60 degrees, and we'd expect if it didn't bend to come out at 60, but it does bend. And it looks like we are sitting at around 41 uh, degrees for the refraction angle. Okay, so how about we switch things up a little bit, and instead of going from less dense to more dense, we'll go from more dense to less dense. So we've got water transition to water. Notice that when the medium isn't changing, it exactly as we expect. The incident angle is 30 degrees and the refraction angle is also 30 degrees. But now if we transition it so that it goes from water to air or more dense to less dense, we'll see here again that 30 degrees, it doesn't come out at 30. In fact, now that's 35, 40, that's about 42 degrees. Okay, so it's increased the angle of refraction. So we've got an incident angle of 30 degrees. We've got an angle of refraction of 42 degrees. So we have the light ray here is bending away from the normal. It's going further away from the normal. We expected it to be here without refraction, and it's got a greater angle from the normal. So this is an example of more dense to less dense. The light will bend away from the normal. When we go back to um, water or air to water like we were doing initially, you'll see here that we'd expect it to be at 30, but it comes back here to about 22, I think it was there. And that is bending towards the normal. All right. You may, in the next day or so here, get an opportunity in class or online here to take a look at this app and play around with it and actually get some data so that you can make some connections of your own. Okay, and coming back to our last slide in the PowerPoint, just coming back and looking at our diagram for angles of refraction. This diagram, again, we're transitioning from air to diamonds, and we've got our boundary surface right here to transition. This is our normal line. I want you to notice that for the incoming light ray, the angle of incidence is fairly large compared to the angle of refraction of the light when it passes through the boundary here. And so that should tell you about something in terms of what side is more dense, what side is less dense. Okay, and if you think back to what I just said a few moments ago here, you should see that it's bending towards the normal, okay, which means it should be going from less dense to more dense. Okay, and in terms of testing, that's what we'll be looking at. You'll be expected to look at a diagram and decide which substance between the two boundaries or on either side of the boundary, which substance is more dense than the other. Okay, and you should be able to tell that by looking at the incident angles and the refracted angle. And you don't have to measure them, but you should be able to see that one angle is larger or smaller than the other.